Yo, students, welcome to lesson 7.5, Similarity in Right Triangles. It's about to happen. Open up your ears. Here we go. Similar right triangles. What do we know? This is a mouthful, so get ready. If an altitude is drawn, an altitude is drawn from the right angle of a right triangle. All right, and remember, an altitude is when you take a line from the vertex and draw it down to form a 90-degree angle at the base. All right. So if I draw an altitude in a right triangle from the right angle, then the two triangles formed, and these two triangles that are formed is this small guy right here, all right? And then we have this guy over here. See, I got two triangles that are formed. They are similar to the original triangle, which is BAD, the big triangle right here. And all of these triangles, therefore, are also similar. All right, so basically there are three similar triangles. This small guy right here, this guy right here, and the whole big triangle. And if you look below, I broke it down for you, okay? There's three triangles that are formed. You have your original triangle, which is BAD. All right, that's the big one. We got BAD. That's our big triangle, okay? So triangle BAD is our original triangle. Let's get rid of that for a second. Then we have our second biggest triangle, right? And that would be this guy. That would be DAC, right? So DAC. That's our next triangle. And these two triangles are similar to each other, right? This one and the bigger one. And then finally we have our little baby triangle, our little baby triangle, which would be this guy, ABC. And that's our small triangle. All right, and these three triangles that are formed are similar to each other. And with that, we're probably going to use that theorem to solve some problems. So I hope you're ready because it's all about to happen. Well, let's start with the basics. If you look below, write a similarity statement for the three triangles in the diagram. There are three triangles, the big one, the medium one, and the small one. We're going to write a similarity statement and label the three triangles below. So what are our three triangles, okay? Well, let's start with the big one, okay? We have our first triangle that is, let's see, let's label this properly. Our right angle is K, okay? K goes to L, which is the shorter side. KL is our shorter side, so let's label that properly. We have KL right here, KL, that's the shorter side. And then we have J on the outside. So that's our big triangle, triangle KLJ. All right. Remember, you got to be accurate with which is the small side. You can't just label it all hibbity-dibbity. We have our next triangle, which is the second biggest one. And our right angle is right here, right? So that's our altitude. So we have Z right here. The smaller side would be ZK in this one. So K goes right here. And then we have J over here, right? So we have ZK, J. Oh, I outlined that horribly, but you get what I'm doing. Triangle Z, K, J. Z, K, J. All right. And then finally we have our small little guy right here, right? And our right angle, once again, is at Z. It's right here. So we're going to put Z as our right angle. And this would be our shorter side, ZL. So ZLK. ZLK. Look at that guy. He's so cute. ZLK. I love them. That's our smallest triangle. So triangle ZLK. Okay? So those are our three similar triangles that we can draw within this triangle, and all three of them are similar as we stated right here. All right? This drawing that you're going to do is coming really handy for solving the next two problems. Come, follow me to the next slide. Boom. In JML, we know LM is equal to 3. So LM is right here. We know that's equal to 3. We know LJ, which is right over here, is equal to 9, and we know JK is equal to 12. What is the value of X, which is missing right here? Now looking at this, we're like, whoa, what the hell do we do? But if we break this up into three smaller triangles, I have a feeling we can do this. So let's start. Let's first draw our three triangles and label them, okay? So we got our first smallest triangle, which is J. I mean, this is our biggest triangle. J is our right angle, L is our smallest side, and we have K right here. So we have JLK, right? That's our first one. So triangle JLK is our smallest one. Now we have our next biggest one. The right angle is right here. Remember, that's the altitude, so that's at M. So M is our right angle, and our shortest side is JM. All right, so we're going to label that as our shortest side here. See how that corresponds? And our biggest side, well, let's see, let's draw it out. We have K. So JMK is our other triangle. And then finally, our third triangle would be over here. Once again, our right angle is right here. All right, let's draw that out. Look at that right there. And our right angle is at M. The shortest side is ML, if you're looking at this, and the bigger side is J, so we put that there, and that's our final one. So triangle JLK is similar to JMK, which is similar to MLJ. Those are our three similar triangles. Now we're not done yet. Now we have to label our sides. And then since they're similar, maybe we could do some solving. So let's do some labeling, okay? So JL is 9, JK is 12, and do we know the whole length of JLK? No, we just know this part, so we're going to leave that blank. So we have 9 and 12. JMK, so we know JM is X, all right? We don't know what that is, but we will put an X there, okay? We know MK, well, actually we don't, so we can't put anything there. And then finally, JK is 12. Okay, and then finally we have our third guy right here, our little pipsqueak. We know LM is equal to 3. We know MJ, let's see, is equal to X. And then we know LJ is equal to 9. All right? And using this information, we should be able to set up a ratio, right, to do this. Now, this is the kind of part that takes that art, that finesse of mathematics. You have to be able to set up an equation, right, that would help you out here. And looking at this, I see a few. I don't know if you see any, but I see a few. Does anyone see one? Oh, am I alone here? No? Yes? All right. I'll give you an example of one ratio that I could set up, right? Looking at this, I see that if I wanted to solve for x, I could say 12 is to 9, right? These hypotenuses of these two smaller triangles, so I'm going to write that. 12 is to 9. This is the big hypotenuse, right, over the small hypotenuse. I don't know why I'm writing it like that. So 12 is to 9 as x is to 3. Right? So I could set that ratio up to solve. Well, now I could solve it, right? So I'm just going to cross multiply. So 12 times 3 is 36. 9 times x would be equal to 9x. To solve for x, I'm just going to divide both sides by 9. And I get x is equal to 4. Big-a-boom! Did it. Good for us. All right? I'm kind of proud of us there. We did it. We did a pretty good job there solving. And, you know, we deserve some credit on that. Were there other ways to solve this problem? Sure. That was just one way to do it. Let's do it another way and see if we get the same answer. I'm kind of interested to see if that works. That was one way. You can keep that on your papers. And if you're interested in seeing another way, go for it. If not, fast forward me. I don't care. Here's another ratio that I think I could set up. I could do 9 is to 3. So 9 is to 3, the legs of these two triangles, as 12 is to x. All right, 9 is to 3 as 12 is to x. Once again, I could just cross multiply now, and I get 9x is equal to 36. Doesn't this look a little bit familiar? Divide by 9 is x equal to 4. So look at that. It doesn't matter which ones you set up as long as you set up the right ones together. Remember, they have to be in the same place. I can't say 9 and 12 because those aren't in the same places there, right? I have to say 9 is to x, or sorry, 9 is to 3 as 12 is to x. They have to be in the same. All right, we're going to get a little more difficult here. In the figure below, CD is equal to 12, which is right over here, and CB is equal to 5, which is over here. What is the length of AC and AD? Well, you're lucky. I'm going to teach you a little trick for this one, and it only works for these kind of problems. So when you have the two bottom pieces, right, like over here, C to D and C to B, when you have these two bottom pieces, you can use the trick that I set up for you right here, which is the side 1 over the altitude equals the side 2 over the crap. Okay, this one's going to be a little more difficult. In the figure below, CD is equal to 12, which is over here, and CB is equal to 5, which is over here. CD and CB. what is the length of AC and AD? Well, AC, which is our altitude, we're going to put an X for it. And there's a little trick that I'm about to teach you, and you're welcome because it's about to happen. And you can only use it when you have this situation. So when you have the two pieces of your hypotenuse on the bottom like this, so when you have the first piece and the second piece, which we're going to call side 1 and side 2, you could always use this little formula over here to help you out. And it works like this. You do the side 1, which is 12 in this case, over the altitude is equal to the altitude, which is x still, over side 2. See how cool that just was? That just saved you so much time. You didn't have to set up all those damn triangles. You're welcome. You are welcome. Now, we just cross multiply. 12 times 5 is 60. X times x is x squared. And to solve for x, we're going to take the square root of both sides, leaving us with the square root of 60 equals x. Now this trick helps us find the altitude. So we know x is equal to the square root of 60. But finding AD is a little different. And sometimes you'll have two-step problems like this, where you find the altitude first and then you have to find another side. The way we're going to find AD is to use our old friend, the Pythagorean Theorem. Why can we do that? Because we have a 90-degree triangle and we know two of the sides. So to find AD, which we have right over mya, we just have to plug it in. So a squared plus b squared equals c squared. In this case, our two legs are 12 and the square root of 60, so it's going to be 12 squared plus the square root of 60 squared equals AD, or in this case it's our hypotenuse. This gives you 144 plus, put this in your calculator with the parentheses. If you do that, you should get just straight 60. The square root and the square cancel each other. Bop, bop. And that gives you c squared. We add these together. 204 equals c squared. Finish it off with your nice little square root, and bam, we get the square root of 204 is equal to c. Let's bring that up. Put it in over here. The square root of 204 is equal to AD. And that is it. So just to give you one last reminder, when you have side 1, the altitude, and side 2, you can use this little trick over here, and it only works in this situation when you have this setup. And 2, sometimes you're going to have to find the altitude first, plug that into the Pythagorean theorem, and solve. All right, guys, remember, Noelia is not as smart as everyone says.